Heather, not here. Laura, not here. Alex, both Alexes. 100% attendance of Alexes. Kirill. Is that how you pronounce that?
I just go by
K. Okay. Benjamin. Justin. Malik, not here. Isaac.
Here.
And Cole. 100% attendance of Alex's and Cole's. Good job, everybody.
Okay, thank you.
Okay, now we go.
Okay,
They
that's.
both have long hair, and like super similar faces, just one wears glasses.
I don't know. I can tell them apart, but
Well, 'cause
yeah.
I'm like,
Exactly. I don't think there's a California forest fire going on.
I don't have any idea.
Yeah, that's weird. It's like, you know, it's just the same. I don't know.
Yeah.
those windows are hard.
Oh, it's just humid though, I would think. Yeah. But that doesn't explain why it's polluted. Oh, outside.
Now it says cloudy, of course.
Okay, so this is dynamics. I'm going to start by just going through the syllabus, the class structure. All of you have had my classes before. It's exactly the same as my other ones. But actually, I think I might have tweaked a couple percentages for the grades and that kind of stuff, but it's basically the same. I want to show you where stuff is on D2L. And then we'll get into a little bit of mathematical preliminary stuff because this is an hour, 20-minute class, I think. I forgot to look, but I think that's correct. Okay. So this is the D2L site, and every assignment I give is going to be, everything I give is going to be on D2L. All my lectures are going to be videoed, and notes are going to be available for them if you miss class or you want to look back at them later. And that stuff is all going to be available on D2L. So this is, you know, the base, home base for everything. Just get in the habit of every day looking at the announcements. Anytime I put something new up, I'm going to put up a new announcement. So that'll tell you where to go. All of the files are in the content section. Course information has a bunch of like references, and then it has the syllabus, so we'll come back to that in a second. And then all of the daily assignment problems, I'll talk about the different kinds of problems and stuff, are here under assignment problems. And solutions are available to these. And so a lot of these problems I assign are going to have full solutions available. You just have to be sure that you don't start just sort of reading off the solutions before you try to do the problems, or you're not going to learn this material. You know, the way to do these problems is to try to do them as if there's no solutions, and then use the solutions if you get stuck, or to compare your answers to at the end. Okay. But those are here. And, yes.
So, for example, for this week, for example, just cover vectors, or is it cover all of them?
That's not; those aren't weeks. So after every class, I'll tell you which problems to work on and stuff. So you know, like today, we might do numbers 1 through 9 or something in vectors. You know. Yes, this is the whole semester's worth. That's right.
I like the last row where we had the white.
It's true. Well, now we have chalkboards.
I spend most of my time with chalkboards after class band.
So is all the homework going to be 1 through 8 on this?
All of the, we'll get into it a little more with the syllabus, but all of the daily assignments, which you get very little credit grade-wise for, are going to be from these, and then there'll be other things that you can think of as more kind of take-home tests or whatever. But yeah, most of, like, really the heart of the class is this stuff. If you get to the point where you can do all these problems and you could explain to someone who asked you questions about a problem why you have to make this decision or this decision, then you'll do great on the tests, great on, like, everything is kind of run by these problems. Yes?
Will there be more weekly assignments this year?
Yes, there will be more. That's my intention.
Are these just the dailies, so what separates the daily and the weekly? Is it just more sparse?
Well,
Or is
it is more sparse. Really, these are, I'm going to have you turn these in just to keep you on schedule, but I'm not going to grade these. I'm just going to check off whether you did them or not. And then maybe 5 to 10 times during the semester, I'll give these weekly assignments where you're going to turn them in. You won't have the solutions available to you, and I'll actually, like, grade them the way I do tests, you know. So it's just a way to give you more feedback on it. Yep.
We'll get that week to work on it?
Yeah, you'll get a whole week at least to work on it, yeah.
Because there's not enough class time to get more than half a problem in a test.
Yeah, that's part of it. Although we have an hour 20 here, so you can fit a little more in. And then these are old lecture notes from a previous semester. If you are interested in skimming ahead or, you know, seeing what's coming up, or if you don't understand something that I say in class, this is maybe a slightly different way of explaining it or something. Okay, so that's everything that's available in content. So let's go to the syllabus and go through the class structure. My office, call me Gaio, just call me Gaio. My office is right up the stairs at the end of the hall. Office hours are not going to be in my office, they're going to be in the tutoring center. But if you ever want to meet outside of office hours, send me an email and we can set up a time to meet. The best way to get a hold of me is email. I don't even have a phone in my office, so if you leave a message, I get an email that I got a message and I check it, but email just is quicker. Yep.
Is 2190, is that the room just up the stairs at the end of the hall?
No, let's see. It's on the second floor, and then it's a little bit to your left, but it's the big glass room. It's pretty easy to spot as you go by. And it's the one right on the corner, like if you're going this way down that big hall, and then you take a right down the main hallway, it's the one right on the corner that's all glass. Yeah, it's a nice place, nice facility. Again, you know, we don't get pay increases and whatnot, but they do have some really nice giant glass rooms and big TVs and stuff. So that's good. Class time. You're here, so you don't need to know this. It's the people who aren't here who need this information, but I'll get it to them. My office hours are Monday 12 to 1:20 and Friday 1:30 to 2:50. But I'm planning on meeting with people outside of those times too. So please, if you want to meet outside of those times, feel free to send me an email and we'll meet. We can meet over Zoom too, if that's better for anyone. Prerequisites. So Physics 1, Calc 2, and a co-requisite of differential equations. Those are just the prerequisites that they have at the U. So that's what I use, but you could be fine in this class without differential equations, and you could be fine in this class taking Calc 2 as a co-requisite. Yeah.
Does statics not have any bearing on this class?
Statics does help with this class, but you can get by without it.
Oh, okay.
I think at the U they combine the dynamic statics.
It depends what what department you're in. In mechanical, you're right that they do that. In aerospace, they're two separate classes.
I'm looking for electronics, and that's, they want it combined.
Yeah,
All into one.
right. So, so yeah, for people who want I think it's a combined 4 credit at the U.
No, it's one, I think.
Oh, one credit?
They take the 2 classes and combine into one.
Oh yeah, one class. But I think it's a 4 credit class.
Abby Math is a 1 credit class.
Yeah.
All my research
Yeah.
showed it's pretty weird, 'cause
They said,
Maybe there's something different for electronics.
But you only get half a credit or half a credit. I'm just like, what?
Yeah.
You have to do that?
I think what it is
Is it like
so you have to take these 6 credits here to get credit for the 4 credit class at the U. So you get a little bit, docked for that, but it's not too bad. But if you're going into aerospace, you have to take the 2 separate classes anyways. Nobody here is going into aerospace, however, so yeah. Materials needed. There is no textbook required. I listed 2 there that I think are good ones if you want a book for future reference. And that is the book that they used for dynamics at the U, so that seems like a good one to get for a lot of people. But I would recommend, even if you have those books, stay out of them during this class. I'm planning to tell you, I'm just trying to make it as clear as possible how to get to the point that you can do well on the tests I'm going to give you and stuff. And so going to other stuff just makes it a little more confusing, Yeah.
You basically, you print out your textbook. All of the important stuff.
Yes, exactly.
Or 20 of them.
Yeah, exactly.
For calculators, just trying to make sure, I don't have a course with, but I have
Yep.
a TI 84. Do I need to get a TI 80 or 89?
Nope, that's perfect. So what does it say? It says preferably, so TI calculators are great because I'm used to them. It can be sort of nice to have one that does eigenvalues and eigenvectors. That model does not, but in this class it won't matter. And it matters less and less every semester because there are better and better websites for just doing it on your phone, So yeah, that's perfectly fine. Okay, and then there's a bunch of topics that we'll go into. I don't really have anything to say about those right now. Okay, so now the grading for this class. Most likely the grading scale is going to be 92, 82, 70, 60. If people score lower than I expect on stuff, then those might be relaxed a little bit. People often get nervous when they see the 92 and 82 because it sounds like a hard grading scale. But really, that's just because my exam questions are very similar to my homework questions. And if you do the homework and stuff, you'll do well on the exams. And so I don't think you'll find that these grades are hard to get, And then the breakdown for the grades, 10% lecture quizzes, 10% daily assignments, 30% weekly assignments, and 50% in-class exams. So now I'm just going to go through each one of these categories and describe it a little bit. So first is lecture quizzes. Basically, almost this whole class is determined by your ability to solve problems. But these lecture quizzes are designed to make sure that you're going back and reading your notes and remembering stuff I say. So this is the one thing that isn't about problem solving. The way to get ready for these is just to skim back through your notes, look back through your notes periodically, okay? In order to be good at doing the problems, you need to remember the stuff I say. That's what this is based on. These are just going to be short answer questions. And so the way it's going to work is on Mondays, maybe every other Monday, maybe every third Monday, that kind of thing. In the last 10 or so, 10, 15 minutes of class, I'll give you a handout with 5 or 6 questions on it, and you'll just spend the end of class just trying to answer these questions. Yep.
When you say Mondays,
Okay, then I guess let's call it Tuesday, but I better change that on here. Thank you. It is definitely Tuesday today. And one thing about these and really about everything in this class that's a little bit unusual is everything is cumulative. So to get ready for a lecture quiz, you need to go all the way back to the beginning of the class and skim through your notes. Okay. It's not like the quiz is just the stuff since the last quiz. Okay. And I will drop the lowest 2 quiz scores from your grade. So if you can miss 2 or you can do badly on 2 and that doesn't show up in your grade.
I'm sorry if you already said this,
Yeah.
but is this something where we have like our notes in front of us type of thing? Or is
Nope.
Okay.
This is, and so basically, this is kind of my thinking on this. Like Alex was saying, in a lot of engineering classes, a lot of classes, you're given a book this thick or whatever, and you're assigned reading out of it, and you're supposedly kind of responsible for 400 pages of reading over the semester. I've done my best to cut down the amount of material you're expected to know dramatically to just the stuff that I say in lectures. And I'm doing that so that you'll spend the same amount of time really remembering the stuff I say in lectures well, as opposed to having a vague memory of some of those 400 pages in the textbook, you know. And so
You don't understand what the quiz questions are. You're probably going to speak gibberish to me for 2 weeks anyway.
yeah. I will, on these quizzes, I try to focus on what I consider to be the big topics. I don't try to like catch you on like minute details or whatever, but I do want you to take your notes and then go back and read your notes and then go back and skim your notes and then go back and read your notes just as the semester is going on. That's the way that stuff sticks in your head a year from now or whatever, you know. So that's what I'm trying to do with that. Daily assignments. So after every lecture, I'll give you problems to work on to solidify what we've talked about in class. The solutions are available to all of those problems. So if you get stuck or you get done and you want to check your answer, that's available. Yeah. For the quizzes or for the, those are just short answer questions like, I can't think of what one would be in dynamics right now. But just stuff that comes up in lectures. Like maybe I would say like, okay, what's the cross product of the x-axis and the y-axis, you know? And something that comes up in class that I consider to be important for your understanding of the material, you know? Not like when I come to class and complain about my dog or something, you know, but like the more important stuff that I bring up.
for example, cross product of x and y axis, and just give a paragraph, a small paragraph.
Show the z-axis.
Yeah, just write as little as you can, because then that's less for me to read. One word or 2 words usually does it on these. Yep. Okay, and then so the daily assignments, you'll turn those in on D2L as a photo file or as a PDF, so you can scan it or just take a picture. I am not going to grade these carefully. You have the solutions available to you anyways. I'm only collecting them and making sure that you're turning them in just to keep you on schedule. So I'm just going to give you a 1 or a 0 for an assignment. If you don't turn it in, you get a 0. All of the weekly assignments, and it's a lot because we have 16 weeks, 2 days of class a week. So, you'll get 32 daily assignments, and all of those add up to 10% of your grade, which is not very much, But understanding these daily assignment problems is the biggest thing you can do to do well in this class. So you need to do that stuff. I'll drop the 2 lowest scores. So basically that means you can miss 2 assignments and it doesn't affect your grade. And then the weekly assignments, basically I would love to grade all the daily assignments, but it's just too much grading. So instead, I do these additional weekly assignments interspersed throughout the semester, where these you'll turn in the same way, but I just go through these carefully and give you points on each question and try to give you feedback on the question so you have a better sense of how you're doing on stuff, how well you're understanding it. If you're doing well on the weekly assignments, you're probably going to do well on the exams when they come. Let's say, so there'll probably be 5 to 10 of these over the semester. I will drop the lowest one of these scores from your grade, and all of those add up to 30% of your grade. So say, 4 to 9 of these assignments come out to a total of 30% of your grade. I am always on these assignments, by the way, gonna give you problems from back previous sections to make sure that you're going back and looking at old stuff.
So never at any real point can we assume that it's going to be on last week's material?
That's right. That is how the daily assignments are on the stuff that we're doing at the moment, but everything else, I want you to keep trying to remember all this stuff, and my motivation for that is just that I remember getting out of classes where I worked my butt off and got done, and if someone asked me what the class was about, it would have been hard for me to come up with a coherent answer, and I don't think that's a good way to remember this material, So I just want to help you sort of keep this stuff in mind, so in 6 months, you still could say something intelligent about what you learned in this class, The weekly assignments. So this is the one area in this class where cheating could potentially be an issue. It normally isn't, but just to be clear about the distinction to me, I love for you all to work together on stuff, but I want you to think of working together as being, the purpose of that is to understand how to do the problems. Once you understand how to do the problems, I expect you to go do the problems on your own. So if I get multiple assignments that look identical, equation for equation over spots, I don't want that, okay? I want you to talk to each other, figure out how to do the problem together, and then go back and write out an assignment that shows me your understanding, okay? And then the biggest part of the grade is exams. There are 4 of these. They add up to 50% of your grade. So each one is worth 12.5% of your grade. These, like all the other stuff, it's all cumulative. So you need to go back and look at old problems to get ready for these. The best way to prepare for exams is to go back over your old daily assignment problems. And as a general strategy, I would say the way to do it is start at the beginning, start at the first problem, look at it, ask yourself, do I know the steps to do this problem? If you do, then move on to the next one. If you're hazy on it, you don't know what to do, then spend a little more time on that problem, and that way you can you might not be able to get through all the problems for every exam, but you'll be able to get through it. You'll have the time to get through it multiple times in this semester, and it'll just stick in your head better.
Are there times or room down for the exams? Or is it just the date?
Man, I have these dates wrong too. I don't know what class I was thinking this was, but there's no Wednesday classes. Okay, I'll fix all this.
I think that's the same.
Okay. Well, so I guess we'll probably do exams on Thursday, I guess. But I'll change all these dates and get this syllabus fixed.
They'll be in class.
Yeah, that's right. And then the final period, that is already determined. I can get you that information, but I don't have it right now. But that's during finals week. Yep.
Is the exam for cumulative as well?
Yeah, everything's cumulative.
Oh,
The-
so even the tests can go back?
Yeah,
Okay.
every test. But the good news is, I will say, this is a pain. I know everybody finds it a pain. I can't really help that. But when you get to the studying for the final, you're going to be happy that it's been cumulative all the way up to that point, because you won't be going back and oh my God, what is this? I don't recognize this at all, Yes.
Statics is kind of a class that naturally built on itself throughout the year, so I assume dynamics is the same way.
Nothing is that way as much as statics. Statics is the most that way, but dynamics, it's somewhat like that. But it's a little bit more like separate topics.
So because exams, we don't get any type of note sheet.
I'll give you all the equations you need, but no note sheet. And then, yeah, don't copy people's work. That's all. I really have had very few issues in my engineering classes, so I'm not concerned about that. Here's a phone number to see if class is going to be canceled. But if there's a big snowstorm or something, as soon as I find out class is going to be canceled, I'll put it on D2L, so you can just look on there too. And then this is the contact information for the OSD office, which is a really useful, really good service provided by the school. Great people. So if you think you might be able to take advantage of what they do, give them a call. And then here's this thing again. Stupid thing. That doesn't mean anything. Ugh. Okay. Any more questions about the syllabus or the class? Okay. I like this class. This class, mechanics isn't very often like mind bending. You know what I mean? It's all just pretty workmanlike, but there are some things in this class that are going to mess with your head a little bit, and that's kind of fun, Yes.
I don't know, but you mean mess with your head, like confusing or?
Yes. It's hard to wrap your head around some of the stuff we do. The main thing is when we start doing calculations involving coordinate systems that are spinning. And it's really, it's fun and it's challenging, And why would you ever do that? Why not use a stationary coordinate system? Well, if you're doing calculations in some kind of, like a space station or a satellite or something, the coordinate system represents, you can think of it as a camera, that's the camera is deciding the orientation through which you see the world. And whatever orientation that thing is the orientation of the camera. You can't control that. You're just taking the information that's coming out of that camera. And so if this thing is spinning, your data is coming through a rotating coordinate system. And surprisingly complicated things come up when you are doing calculations with rotating coordinate systems. And so, yeah, we'll get to that later in the semester. Yep.
Would you say it's complicated in a hard to understand kind of a way, or complicated in a workload kind of a way?
I would say more in a wrapping your head around it kind of way. It's not particularly like computationally intensive or anything. It's just knowing when to use it and when not to use it.
Holding on to that one static component while everything
Yeah.
else
Uh-huh.
numbers still come out.
Yeah. So anyways, I like that stuff. It's compared to statics, this is a more mathematical class. There's some differential equations and stuff, but I'll tell you everything you need to know about differential equations for this class.
For the weekly assignments, will we be turning them or D2L as well?
Everything in D2L. Yep. And yeah, I'll say this again when we get closer to the first assignments and stuff, but if you're taking pictures on an iPhone, the default is for it to be in an HEIC format that I can't read on my computer. So I need you to turn, if you're turning in photo files, I need them in JPEG format or something, TIFF format or something that I can read on most computers. PDF is great, yeah. It's just the HEIC, like my computer doesn't do it, and I don't have, I'd have to go to tech support because I don't have permission to load, and install stuff on my computer, so. Yeah, exactly.
So,
There's ways around that.
should we see next week start electric quizzes?
Probably not next week because we won't have done a lot of material yet, but maybe the week after. Yeah.
I'm just trying to figure out when things start becoming due.
Yeah. You'll have stuff. I might assign a couple problems today, but I guess I probably will assign some stuff today. But we'll really get into stuff on Thursday. Any other questions? Yeah.
Oh, sorry, you may have said this, but the daily assignments, will they be due the following class period?
I'm planning to do it like have them skip a day just to give you a little extra time, but I would recommend that if you have the ability to do it before the next class, that you do it. You know what I mean? And that brings up a question about when stuff is due, whether you can turn stuff in late. I will accept stuff late, but you need to contact me about it beforehand. I just want to know, like what you have going on, when you're planning to get the stuff in. Basically, last semester, I said, turn stuff in late, feel free to turn stuff in late, and people waited longer than I think is good for them to turn stuff in, so I just want to keep you on schedule a little better this semester.
With the exams, what kind of structure? I mean, I don't understand it's cumulative, but like 10 questions, 5 questions, 10 questions cumulative.
Want to see one?
Yeah.
Okay. This may not be an exam I give you this semester, though. Yeah. I do try very hard not to give exams where you feel like you're racing against the clock. Okay, let's see what we got here. Exam 4.
Would we get any study guides, kind of things like that, or just use your daily notes?
Yeah, just use your notes and the daily assigned problems. Okay, so here is a test. I think this was probably when this was a 50-minute class, so I had to give a little shorter tests. but there's only 2 questions on this test. And the first one is deriving a system of equations and not solving them. And the second one is calculating the acceleration of a point.
Oh my.
So looks simple, but
No, no.
yeah. It hopefully will be simpler by the time you see this on a test. And then you can see like whatever equations you're going to need for it, I'll give those to you. Any other questions? It's funny, in deform and dynamics both, I guess it was true with statics last semester, like with COVID, it's been like 2 years since I taught some of these classes in person. So anyways, it's sort of newish. And then I was on sabbatical last year, so it's newish to me too. We're going to all learn it together. Kind of kidding. But all right, that's it. So let's get into some mathematical preliminary stuff for the class. One thing, I'm not going to talk about this right now, but I'm going to assign a vector review to you and some vector review problems. It's the same vector review that you did in statics, but it gives you a sense of the kind of problems that you'll have to, the kind of vector approach that you're going to have to use in this class. But what I want to get into today is the derivative and differential equation related stuff. So let's start with derivatives of vectors in non-rotating coordinate systems. And then the product rule for vectors. And then the chain rule for vectors. Each of these is going to be short, and then there'll be one slightly longer one, and that is solving ordinary differential equations, ODEs, using separation of variables. Okay, so I'm going to start with derivatives of vectors. And this non-rotating coordinate system thing is going to be important. So let's say that you have a vector u, and this is the notation for vectors that I'm going to be using and you're going to be using. So the components are written as a column matrix in a square bracket like this. So if you take the derivative of this vector with respect to some variable, let me call it q for now, just some general variable. This is equal to the derivative with respect to q of the first component, derivative with respect to q of the second component, and derivative with respect to q of the third component. So just one by one, you're just taking the derivative of each one of these components. So that's pretty simple.
So it's just like partial derivatives.
No, it's not. It's not. It's a little different. But so let me show an example. Let's say that you have. So let's say that your vector v is equal to 2t cosine t negative e to the t. Okay. So let's say that this is the velocity vector of some object, some particle. Then the time derivative of the velocity, which is the acceleration of that particle, is just the derivative of the first component with respect to t, derivative of the second component with respect to t is the second component, and derivative of the third with respect to t is the third component. And by the way, we're going to use a notation pretty often. Well, first of all, this would be the acceleration of the object as a function of time. We're going to use a notation pretty often where d dt is defined as the thing dot. So you can write this as v dot. So whenever you see a dot over something, that's what it means, the time derivative, the total time derivative, not a partial time derivative. Like if this thing was a function of x and y and t, this is not, and you put a dot over it, that's not a partial derivative, that's a total derivative. Okay, let me give you just a little heads up on what's coming up later on in the semester. Why does it matter that the coordinate system is non-rotating? Okay. Well, this is the notation that I'm going to use for vectors. There are a lot of really useful applications of this notation. You can do a lot of cool matrix stuff with that format. But that vector u that I defined here, okay, remember we can also write this as this u vector is equal to ux times a unit vector in the x direction, I, plus u sub y times a unit vector in the y direction. plus uz times the unit vector in the z direction, k. Okay. What happens if you take the time derivative of this u? Okay. Well, I'm just about to tell you about the product rule with vectors and whatever, but you can believe what I'm saying here, at least I think. Using the product rule, this says this is equal to ux dot times I plus, now here's where the chaos comes, ux times I dot. Okay, and then that happens with the other ones too. Uy dot times j.
We're just curious, why don't we have two X's? Oh, so there's two.
It's because of the product rule. You know, that u, for the vector u, what we have is a component ux, you know, a number ux multiplied by this unit vector I. And so to take the time derivative, you need to use the product rule. Okay, and so that's where you get these terms that we really would prefer not to deal with. The ux times I dot and the uy times j dot, and then the uz times k dot.
That's messy.
And the I dot, j dot, and k dot terms cause problems if the coordinate system is rotating. Okay, so like what if the coordinate system isn't rotating? Then what's the orientation of I at instant 1 compared to instant 2? Well, it's not rotating, so it's the same, right? So what's I dot? If it's not changing over time, then I dot is 0, and that term disappears, and then we're happy, you know? But if it's rotating, then I dot, j dot, k dot are non-zero, and you have to deal with those terms. Okay, so basically this way of taking derivatives of a vector assumes that those I dot, j dot, and k dot terms are 0. Okay, so now let's talk about product rule for vectors.
Just wait on the product rule.
Well, with vectors, there are 3 kinds of multiplication. Okay. So we have to make sure that we understand what we're doing with each one of those. 3 different kinds of multiplication for vectors. Let me look at something real quick here. Okay, 1. So this is number 2. I'm just trying to keep this uniform in your notes. Okay, and I'm going to get this underline out of here. Okay, so the 3 different kinds of multiplication for vectors are multiplication of a vector by a scalar, So let's say that you're taking ddt of some scalar x times some vector u. This is equal to x dot times u plus x times u dot. Then what are the other two types of vector multiplications? Dot product and cross product. Okay, so for dot product, so ddt of, let's say that we have the dot product of a vector u and a vector v. Okay, that's equal to u dot dotted with v plus u dotted with v dot. None of these are surprising, but you just have to be clear. And then the last, yep.
So like on the homework problems, are we gonna have to do them all log again?
Do what?
Or from the homework problems, are we gonna have to do them all log again?
No. If you can use your calculator on it, feel free. I mean, notice it's like if you had never thought about this before, and maybe you haven't, the product rule works exactly like you would guess if you had to guess, you know. But there is one thing I want to point out after I show you the cross product one. Okay, so dt of u crossed with v. Well, what would you guess the answer to this is going to be? U dot cross v, yep. Exactly. Yep. No, I did this wrong. Cross v dot. Okay, but I want to show you something because I don't know how you normally do product rule with scalars, but it's possible that you think of it as like that you would tend to think of this as x dot times u plus u dot times x. And that works in this case. Okay. And that works in this case.
You're saying instead of writing the first one, we can write the second one?
Yeah, so let's see, how did that is y in both of these two cases, that's right. But what is not commutative? Stupid cross product, exactly. So in this case, you can't do that. Okay. So keep the order the same in all of these, and then you never have to worry about it. Is everyone with me on what I'm trying to point out there? Yeah.
So for example, if you give us a frame, I know it's not the case, but
yeah.
D divided the derivative. I always forget the
yeah, derivative with respect to.
If I write the second version, I'd get full credit for a problem.
If you wrote the red version,
yeah.
Yes, that's perfectly fine unless you're dealing with a cross product and then your answer is wrong. Yep. Okay, and then chain rule for vectors. So if you're taking a derivative of a vector that's a function of a single independent variable, this is equal to df dg times dg dt. This is actually going to come up pretty often. So this will come up in dynamics. Like this. So you know that acceleration as a function of time is the time derivative of the velocity. Right? But what if in our application we only know velocity, the velocity vector as a function of, like, say, the x position? Okay. How would you find the acceleration based on that? Well, v of x is really v of x of t, right? That x position is changing in time. And so the acceleration is dv dx times dx dt. And dx dt is the x component of the velocity. So this is equal to dv dx times the x component of velocity. So this is a case where even though we don't know the velocity explicitly as a function of time, we could use the fact that acceleration is the time derivative of velocity to come up with an expression for the acceleration. Okay. So notice that I think it's sort of natural, easy for people to, you're trying to optimize storage space in your brain. So you think like your physics teacher is talking and talking and talking, and you're like, okay, yeah, acceleration is the derivative of velocity. Got it. You know, like, and then you can go back to thinking about Ren and Stimpy or something, you know. Is that still on? Used to be a show. Okay.
Everything's getting reboots these days.
Oh, okay, that's good. Well, so you think like acceleration is derivative of velocity, and that's the end of it. But that is not the case, you know. Acceleration is the derivative of velocity with respect to time. If you take the derivative of velocity with anything, with respect to anything except time, you're not going to get the acceleration. So notice here, if you knew the velocity is a function of x, okay, and you just thought acceleration is going to be the derivative of this with respect to x, you're off by a factor of whatever that x component of velocity is. Let me give you a quick example. We'll talk about this more when it comes up.
So you just have to derive it as a function of time.
You have to use, yes, you have to take the derivative as a function of time, or you don't get the acceleration. So let's say that velocity, and actually let me do it this time instead of as a function of x, let me do it as a function of y, because it can be anything, it can be that too. So let's say that the velocity vector is 2y minus y, y squared. What's the acceleration vector? Okay, so that tells you based on the object's height, you know, how fast or what the velocity is of this object. Well, the acceleration vector is dv dy times dy dt. Which is dv dy times, dy dt is the y component of velocity. So vy. And now we can just fill these in. What's dv dy? So for the x component, that's 2. For the y component, that's -1. For the z component, that's 2y.
Why is it?
And what's the y component of the velocity? Just go back up here to our velocity function, and that's equal to -y. Yeah, just multiply them together. So -2y is the x component, +y is the y component, and -2y squared is the z component. And we use the chain rule there to come up with an acceleration in terms of the height of the object, which it wouldn't automatically probably occur to you that that was possible in this case. And also notice that what we did not do is just say acceleration is the derivative of the velocity, because then we would have just gotten for our acceleration 2 -1 2y, and that would have been wrong. Yep.
Can you explain why dy dt is?
Oh yeah, because the position vector is x, y, z, and the velocity is the time derivative of the position vector.
What was that question? Just because I want to word it.
Yeah. So why do I make this substitution? So in this line here, I have dv dy times dy dt, and then how did I make the substitution of dy dt to the y component of the velocity? Although I think really largely right now I'm maybe going into so much detail, you think you have to understand what's going on this now. Eventually you'll have to, but we'll get to this and do more example problems and stuff later. I'm just trying to give you an example of why doing the chain rule with vectors is going to be important to us. So really all we're doing right now is just mechanically, telling ourselves how we're going to do product rule, chain rule, derivatives when the mathematical objects we have are vectors.
Eventually it's gonna get ugly.
Yeah. Okay, the last thing that we have to do, we're not going to do it today because it's going to take too long, is solving ordinary differential equations using separation of variables. This is the only kind of ordinary differential equation that you're going to have to deal with in this class. We'll do this next time, but let me just define what some of these things are. Anyone remember what an ordinary differential equation is?
Like an equation that has its own derivative as part of the function.
That's a differential equation, that's right. And so what's the distinction is between ordinary and partial differential equations. An ordinary differential equation, or an ODE, is one where, what is going on here? There is a single independent variable or in other words, the derivatives are total, not partial derivatives. How many of you guys have seen partial derivatives? Most. Yeah. Well, they won't come up in this class. That's the good news. But just this is sort of for a mental bookkeeping thing. Like, how do you know when you're dealing with an ordinary differential equation? You don't have any partial derivatives. And what it means is you only have a single independent variable.
I have like x and y both as a function of t.
You could have, so that's a good question. And man, my computer is tired of this lecture. Independent, yes. So you can have multiple dependent variables. So you could have x, y, and z as functions of t, but you can't do derivatives of the pressure as functions of x, y, and z. There has to be a single independent variable. So for example, let's say y double dot plus 10y, that's a double prime, not double dot, which actually is important here.
Does double dot come up?
Yeah, so double dot means just second time derivative. Dots always mean time derivatives. Prime mean you need to look for other contexts to figure out what the independent variable is.
The dot means that we say it on the back.
Okay, so this plus y prime times y squared is equal to 50x. Okay, so this is an ordinary differential equation where x is the independent variable. And what does it mean to solve this? Like, how do you even know whether you've solved it or not? Well, what you're looking for is y as a function of x. You're looking for that function, x squared or cosine of x or something. Okay. On the other hand, so this is a ODE. What about this? God dang. Let me get through this last couple lines. Partial of z with respect to t plus partial of z with respect to x plus partial of z with respect to y is equal to 1. This has 3 independent variables. T, x, and y. To solve this means you'd be looking for this function of all 3 of these independent variables. This is a PDE, a partial differential equation, which someday you'll have to worry about, but not in this class. This comes up a lot in advanced fluid dynamics. And it comes up in advanced solid mechanics too, like continuum mechanics. But unless you have a very mathematical focus, you would not solve continuum mechanics problems mathematically like this. You would use finite elements and just use a software package, and it would be a lot easier. Yeah, this is getting into the kind of stuff you have to solve for advanced deformable body mechanics problems if you're not using a finite element software package. Very few people want to do that because it's totally impractical. It's much harder to do much simpler problems, stuff like that. But actually, I have to admit, this is what my dissertation was in, this kind of stuff. So I don't know why, but I thought it was interesting at the time. Yes, exactly. Okay, so this is what we're going to do next time. We're going to talk about solving these ordinary differential equations. Anybody have any questions? Yeah.
Like on the map, like for the map problems,
Mm-hmm.
we'll be able to solve most of those on Thursday.
Yeah, I think I'll look at them. I think there might be some you can solve already. So maybe I'll assign a few, but you'll be able to do all of them after Thursday. And I'll probably also assign something with the vector review today.
I have a question for back to like the syllabus. Do you have any extra credit opportunities?
No. Nope, I don't have anything like that. All I just really want you to do is just remember every single thing I say perfectly and be able to do all the questions that I assign you. And then you'll be perfectly fine. Yeah.
Is there a emphasis on extra credit, whether it's more frowned upon or whether it's more?
At Normandale or in general?
General, Normandale. With the teachers, I've noticed.
Yeah.
Like, sometimes I want to give up to like 10 points. That 10 points can mean something.
Yeah. Right.
And I assign extra assignments.
I don't know. I know people who do. Yeah. The one thing for people who tend to get nervous about exams, I will say there are 2 things. First of all, my exams are not worth a ton of points, so that's good. And second, I try really hard to make sure that you have plenty of time on the exams. So I try really hard not to make it where people are going to get like frazzled or, like all stressed out during the exam.
Your points are 50% though.
Yeah, all together they do add up to 50%, but each one is only worth 12.5%.
But it's still percentage that's serious percent.
I think
I just,
Yeah.
it's been a year since I was back in classes and I got to redo a lot of stuff.
Yeah.
So that's where I'm.
I gotcha.
So for example, like my one question.
And if you need anything from me, I guess.
Product rule and then derivative laws, when you went from E to cos to negative E T and negative sine T, is that clock diagram where they go from here and it's like.
No, that's just that. Yeah, that's right. Just DDT of sine is cosine.
Okay, so if
DD
I need to redo this, which I know I need to.
This is more like calculus 2 rules.
Yep, that's right.
Well,
Yeah, maybe at the end of Calc 1, yeah.
Chain rule, product rule, and all that stuff was more Calc 2,
It's
wasn't it?
been 2 years since I did Calc 2.
Mm-hmm.
So, and
I'm coming from that behind the curve, so
Yeah.
let's say it that way.
Yeah.
would quotient rule have any place here? Like learning, going back that far, like product,
Are you
chain,
good with your
quotient,
calculator?
things like that?
Get good with your calculator.
And would that have any necessity here to go back and review those?
You can probably just.
It can't hurt, but I don't think you'll find that it's like heavily emphasized or anything.
Okay, because I've never really been super solid on the derivative rules and stuff
Yeah.
like that.
I mean, I'm not trying to emphasize that stuff, but remembering these two is worthwhile.
Okay.
And because of these, the integral of cosine with respect to time is sine. And integral of sine with respect to time is negative cosine. Remember that?
I'll do that. The common and derivative rules of calculus.
Yeah.
Yeah, I probably.
And product rule, not that, like I said, I remember here, product rule is not that clock thing, but